Да, добрый день.
Здравствуйте.
Записывается, да?
Ну, написано local recording, pause или end, как будто записывается.
Пауза это остановиться просто. Ну, сейчас пока на паузу вас поставьте.
Мгм.
So we can start our exams by the research methods. Who will be first?
Okay, so there are three students, yeah?
Yes. Your
Okay,
name? Svetlana Alva.
okay. So let's start.
Yes. Who will be first? Maybe.
Hello, can I be first?
Yes, okay. Please face your desktop demonstration. Oh, okay, very good. Questions? Yeah. Professor Hua, you can see the questions?
Yes, but I cannot understand. That's okay. Okay.
Okay.
Oh yeah. English, yeah, I know. So number one, number two. Okay, I
Okay.
can understand. Okay, please.
Can I prepare 5
Yeah.
minutes?
3 minutes for the prepare.
Okay, please.
We have to give him for the prepare for the questions 3 minutes.
Let me. There are three questions. Yeah.
Yes, 3 questions.
Okay.
For the
So
prepare 3 minutes.
okay. So okay, I know.
Ilnur, it's time to answer the questions.
Okay. First question is indicate the differences of the method of
Ilnur,
low voltage scanning.
you have to open your picture.
Oh, sorry.
Yes,
Мгм.
I demonstrated already.
Демонстрация қосайын ба?
Yeah.
Көрініп тұр ма?
Uh-huh.
First question is indicate the difference of the method of low voltage scanning electron microscope, and the low voltage scanning electron microscope offers differs from traditional SEM, primarily in the accelerating voltage used, and which leads to several important differences and in imaging performance, sample interaction, and analytical capabilities. And lower accelerating voltage operates at accelerating voltage typically below 5 kilovolts, and whereas conventional SEM usually use 10 or 30 kilovolts, and the lower voltage reduces the penetration depths of the electrons into the sample and improved surface sensitivity due to the shallow interaction volume. Low voltage SEM provides enhanced information from the near surface layers of the specimen, and this makes it especially suitable for studying surface morphology and the surface details. And non-conductive and weakly conductive samples experience less electron charging at low voltage, and like a result, low voltage SEM often allows imaging without conductive coatings, preserving the original surface structure. And next is a lower beam damage, and the reduced electron energy minimizes radiation damage, which critical for beam sensitive materials such as biological samples and some nanomaterials and polymers. And higher contrast for light elements at low voltage, the contrast from materials composed of light elements and improved due to enhanced secondary electron emission, and limited analytical capabilities is energy dispersive X-ray spectroscopy becomes less effective at low voltages because fewer characteristics of X-rays are generated, limiting elemental analysis and accuracy, and reduced spatial resolution for some analysis, and also modern low voltage SEM systems can achieve a high resolution, and lower voltage may reduce resolution in some cases due to chromatic aberrations and decreased signal strength. Next question is prove the structure of carbon materials by Raman scattering, and Raman spectroscopy is one of the most effective and widely used methods to characterize the structure of carbon materials, because this method highly sensitive to carbon bonding and crystallinity and structural disorder. And basic principle of the Raman spectroscopy is based on the inelastic scattering of monochromatic light by usually a laser, and this light by phonons in a material, and the resulting shift in wavelength provides information about vibrational modes, and which directly related to the atomic structure and bonding of the carbon atoms, and identified of carbon hybridization like sp2 and sp3, and Raman spectroscopy can characterize two bonding: sp2 bonded carbon like graphene carbon nanotubes shows strong characteristic Raman bands. sp3 bonded carbon like diamond diamond-like carbon produces different vibrational features, and Raman spectra allow confirmation of the dominant bonding type in carbon materials, and G-band graphitic order, the G-band about 1560 centimeter corresponds to the in-plane vibration of the sp2 carbon atoms in a hexagonal lattice. Its presence confirms graphitic or graphene-like structure and band position, and white provide information about crystallinity and strain. D-band structural defects and disorder. The D-band is about 1350 centimeter, is activated by defects such as vacancies, edges, and as many functional groups, and the intensity ratio of ID to IG is commonly used to quantify the degree of disorder, and higher ID to IG ratio indicates more defects and smaller crystallite sizes. And 2D band is a layer number and stacking order, and the 2D band is about 2700 centimeter, is sensitive to the number of graphene layers and interlayer interactions and stacking order, and a single sharp of 2D peak indicates a single graphene, and while broader of split peaks indicate multi-layer structures. And crystallite size estimations using empirical relationships, Raman data allow estimation of the in-plane crystallite size of graphitic domains, and Raman spectroscopy is non-destructive, requires minimal sample preparation, and can be used for mapping, enabling a structure of carbon materials to be visualized. And next question is use an X-ray diffractometer for the analysis of nanomaterials. And X-ray diffractometer is a fundamental analytical tool used for the structural characterization of nanomaterials, and providing information about crystal structure and phase composition, crystallite size, and lattice parameters. And principles of X-ray diffraction is based on diffractions of X-rays by periodic atomic planes in crystalline materials, and when the Bragg condition is satisfied, constructive interference occurs, producing diffraction peaks that are characteristic of the material's crystal structure. And phase identification of nanomaterials is each crystalline phase has a unique diffraction pattern And by comparing experimental diffraction peaks with reference databases, XRD enables qualitative and quantitative phase analysis of nanomaterials and including mixed or multi-phase system, and evaluation of lattice parameters and crystal structure, precise peak positions, LO calculation of lattice constants, unit cell symmetry and crystal system. Changes in lattice parameters can indicate strain defects of dopant incorporation in nanomaterials, and analysis of cross-strain and defects and peak broadening and asymmetry can be analyzed to determine microstrains, dislocations, and structural defects, which strongly influence the physical properties of nanomaterials. And XRD analysis is non-destructive, requires minimal sample preparation, and provides highly reproducible results, and making it suitable for routine and comparative studies of nanomaterials. That's all.
So you have finished?
Yes, I finished.
Okay, so good. And Dr. Sorbet, so can I ask some questions?
Yeah. Yes.
Okay, and in general, it's good answers, but I have several questions. So for question 1, okay.
Mhm.
So for question 1, so I have the questions. Do you know? And for the samples, when you use the low voltage SEM, so do you know the samples are the samples required some special pre-treatment? So what type of the samples when you use the low and voltage SEM?
Which samples we
Which type?
use?
Which type sample?
Not conductive materials, biological samples, nanomaterials can use this method of
So
scanning.
what is the advantages of this method?
Advantages? This is about using fewer
The small amount,
How?
of sample, yeah.
And low voltage SEM is can reduce the charging effects and low accelerating voltage decrease electron accumulation on non-conductive samples, and allowing imaging without conductive coatings, and this shallow electron penetration provides detailed information from the top surface layers, and this is critical for surface and interface studies. And in this method is minimal beam damage, and when we use a lower electron energy, we can reduce the radiation damage to the our material.
Okay. So will you use this method in your, for your research work?
I think no, because this method use it in characterization of a new material. This is not about my research because I will research the process of the combustion, and in this research topic is not important to know the size of materials, and
Okay, I
this
know.
is
So that
more
means, I know. So that means, in your research work, you will not use the lower voltage SEM. Yeah.
this is not the very important methods of analyze, I think,
Okay.
to my work.
So, and for question 2, so can you repeat several advantages of Raman spectroscopy?
Advantages of the Raman spectroscopy.
Yeah.
Uh,
Several. So please repeat
and
several
in
advantages.
in this method, we can take the knowledge about the layer of graphenes and carbon nanotubes, and other methods can't give us this information. This is a first and very important advantage.
So do you know how about the sensitivity? Is high
How?
or low? So do you know the sensitivity of Raman spectroscopy? It is high or low?
This is I think high because this method can analyze the defects and crystallinity and bonding in materials, and this is impossible if the method can't be sensibility, I think.
So do you know, and if you have a liquid sample, if you have a liquid sample, can you use the Raman spectroscopy
Liquid
sample?
I don't know.
You don't know.
Maybe we can't use.
Can't. You
This
mean
is
we can't?
to the only crystallinity
Okay.
samples.
So I have to tell you, and for Raman spectroscopy, so we can use the solid sample, not only solid sample, also the liquid sample, also the biological such as QC. So that means Raman spectroscopy is very can be used widely for all the types of the sample. Okay. Okay. Dr. Stop it. Okay, my question is okay. And then
Oh,
hello.
Hello?
hello.
Okay, my question is okay. And then
Okay, if you finish your
yeah,
questions, you can.
yeah.
We can.
Can I stop my demonstration?
Yes. We can start the second students.
Okay. So please next.
Next is
Thank you.
Svetlana.
Okay. Just a moment. Can you see
Yes. Okay.
my screen?
Yeah, I think. Yeah, I can see
For
the question.
prepare, we give you 3 minutes.
Can I read my questions and start my answers?
Okay, please.
In my ticket, I have 3 questions. The first is to point out the differences between electron beam lithography and nanomanipulation. The second one is formulate the characterization of metal nanomaterials by Raman spectroscopy. And the third one is show the diagram of the ultraviolet spectrometer and justify the principle of operation. I would like to answer according to the first is all of these research methods are physical and chemical methods to help us in our research work. I'm not planning to use it while doing my research. The first one is about to work with very sensitive and small volume samples, specifically used in nano materials and nanotechnology science. The difference is that the structure in electron beam lithography can change in comparison with the method of nanomanipulation, and all of them are pretty different and pretty difficult, and common, what is the general for both is they are implemented while doing the research in nanotechnology. The second is also used for searching in nanotechnology and nanomaterials. It's the same method as Yelnur was discussing, and Raman spectroscopy is used for scanning the structure of different kind of materials in solid forms and others, and the major characteristic of this method that it can highly demonstrate the in high quality demonstrates the structure of different kinds of materials, not only the structure in while using for finding the number of materials, but also for searching for the precise percentage of each which are involved in a common volume of the material. The third one is to how can I explain the ultraviolet spectrometer and its work is that the major principle of working this kind of tool is to that the atoms in the volume of the material can be scanned by ultraviolet rays, and it can determine the specific structure and the size of molecule of different kind of materials. All these methods are very useful while doing the research, especially in nanotechnology, and we have the opportunity to use them in our university. The first point is to prepare the specific samples. The sample has to be a specific size. For example, consists of a very small small pieces of the material. Sometimes it is very hard to prepare the sample because we have to reach the specific size, not more than it can be used in a specific tool. The first is to prepare the sample and to prepare the sample and to it also we have to take it in mind to some samples can be destroyed while they're researching and we have to put it in mind. I'm ready to answer the questions according to my answers.
Okay. So in fact, there are three questions, but I think for question one, I don't think it's easy for you to understand. To point out the difference between electron beam lithography and nano manipulation. Okay, for question three, so you have to show the diagram of the UV spectrometer, yeah? Also, I don't think it's easy for you to answer the question, but I think your answers are very good. So I have one questions and for your question two. So because for before for the Raman spectroscopy, there are many advantages and for testing the materials. Okay, so please repeat and summarize at least 4 advantages for Raman spectroscopy. So please start.
Raman spectroscopy is the methodology of researching, of working with different kinds of materials, nanomaterials as well, and the general advantages of this method are the first is that this method is very high sensitive. This method is popular. This method can involve different kinds of materials in different forms, and also from my point of view, this method is very доступный in English. I don't know in English. It is not limited.
Okay, so if you have a mixture samples, so if you have a mixture of a sample, can you use Raman spectroscopy and to confirm some properties?
I think that we can use mixtures to determine which exact materials are in the content of this mixture using this method.
Okay. Okay, good. Okay. So
It's remaining time only 1 minute. I don't
okay, so please open a new
open
new
new
account.
one. Yes,
Okay.
new
Okay,
conference. Okay.
Okay, so thank you. So it is okay.
Thank you.
Мне выйти и заново зайти или как?
Да, сейчас я новую создам, надо будет заново зайти, потому что времени не хватает уже.
А, хочу.